a lot of these so-called celebrities or, the big guys, I will sleep for 4 hours a day and all that is a BS. Actually living in two different worlds.
You also mentioned something about taking an afternoon nap. It is also considered unhealthy to have a nap right after a meal.
We listen more to outside advice than listening to our bodies ourselves. For example, there's oxygen deficit at one place. So the cell has utilized oxygen. This, when you are sleeping, the actual performance of that cell is temporarily suspended.
There can be low sodium in somebody. That leads to their brain not functioning as much as it should.
That directly affects the signal transmission.
Okay.
So suddenly there will be an influx of sodium into the cell and then the influx of potassium out of the cell.
If somebody has a problem with their spine, how do they know whether to go to an orthopedician or neurologist or a neurosurgeon?
This confusion is there. Countries where, like say in UK and all that, where neurosurgeon is not accessible directly to any person who comes for a referral.
Pain is not actually in one part or another. Pain is in the brain.
You have sensors all over your body, which is not good. It's harmful for your body.
Do you think it is actually a good thing?
Yes.
That you feel pain?
See, now since we have become sedentary, the muscles get weak and the bones are getting more pressure. The muscle is not supporting the back enough. So the bone, since it is hard, it will tolerate that stress. But between the bones, there is something called as a disc, which starts getting damaged. We pop in some painkillers or some muscle relaxants, and then probably 30-40 years before, when we had this kind of symptoms, we used to take some amrutanjanam or something and then we used to sleep. Comes out more severe pain than years before.
There was this thing called midbrain activation. We have some exercises that are going to activate your midbrain and that will make your kid super smart. They'll be able to close their eyes and see what is going on.
Definitely, it has all the centers which create awareness. We talk about soul and all that. No?
Can you tell us a little more about dopamine? What is its role?
Superstar or your Ronaldo scored a goal and he has won this game. You feel good about as if you have done the thing. Smoking will give you positive depolarization.
Now, how is sleep different from a coma? So is it possible to surgically join nerves?
No.
It's not. Hi everyone, welcome to this second episode of DoctoPod. We are here with Dr. Krishna Chaithanya. He is a neurosurgeon based out of Bengaluru, and in the very first episode was again with him. We had a little bit of an introduction about him, and today we are going to be talking about a few topics around neurosurgery. This is the first among the few episodes that we are going to have. So let's gear up.
Yeah.
All right.
All set.
All set. So, right before this, we were talking about, general good habits with respect to neurosurgery.
Yeah, I think in that discussion itself, when we were having that, I guess I was telling you that the body doesn't compartmentalize a good, healthy practice. So, I think in general, we have a good set of healthy habits which we all know and which I guess even our parents keep telling us, that we should do this and all that. So I guess maybe we can just enumerate a little bit now in the context of the brain and spine for that matter. So I think the most important is the good night's sleep, uncluttered sleep. And this is usually we have a tendency to take in our mobile and keep on seeing the mobile till we actually, our eyes start burning. I guess that's a very wrong way of sleeping nowadays. In a way, maybe the previous way we used to sleep was better in the sense we take a book and read that because you don't have that bright light coming into your eyes. So good sleep. So we usually tend to see a lot of these so-called celebrities or the big guys who are there. They say that I sleep only for 4 hours a day and 3 hours a day. That's wrong. I mean, people shouldn't promote that kind of whatever, because whatever said and done, a person needs around 6 to 8 hours of sleep as a must. Okay, some people may need 6 hours, but some people may need a little more than that. But 6 to 8 hours is the range in which we need to sleep. Okay, so and if you really look at it that way, these very successful footballers, the guys who even in spite of taking a good night sleep, they also have their afternoon naps because it's very essential for them to maintain both the mind as well as the body's ability to the peak of performance. So this whole concept of I will sleep for 4 hours a day and all that is not. It's a BS according to me. Okay.
Yeah.
So body needs that much of time to recalibrate itself for the next day. So that's it.
So do you think a body knows how much it needs to sleep?
Yeah, why not? See, I mean, I always believed in this kind of system where we are actually living in two different worlds. As in, one is a real world which is without any language. Okay.
Okay.
It's like the hardware and the software basically.
Okay.
So, wherein, in spite of we giving a definition to whatever is happening in the real world, it happens irrespective of whether you put in a particular property or a language to that or a definition to that.
Okay.
The other set of world is a virtual world where we are giving a definition, like we talk about sleep. Okay. Sleep means then we understand what is sleep is you go and So we have a definition for everything.
Okay.
So that is, you try to understand the real world function through a definition and you attribute some properties to that.
Okay.
But then doesn't mean that all the properties which are actually happening in the real world are we are already understood, grasped or understood. So that is the thing. So when you talk about sleep or any other thing, we have to understand that there is always a gray area which we are not understood. Okay. So in that, coming to your point, yes, body, irrespective of our virtual world what we are in, the body has been there even before that. When did language start? In human beings,
maybe
it started
a few thousands of years
10,000 to 20,000 years back.
Maybe.
That's it.
Yeah.
But the bodies have been there from billions of years, right?
And for that matter, every other organism, they don't necessarily talk or anything.
Exactly. And they're still intelligent.
Yeah.
You see, an octopus, it's not even a vertebrate, but it's much more intelligent and it shows features of intelligence which we now are, we are surprised about. Wow, how does it do like that? So I guess we have to come out of our virtual world we live in and then try to connect with ourselves much more deeply. That's what is important.
So, is it fair to say then that there may be some people who might require more than 8 hours of sleep and their body would tell them if they need more than 8 hours
definitely.
of sleep?
I mean, see, eventually you need to realize that to feel, fresh and, active, you need some amount of time. And yes, like for example, I'll give you the example again. A larger built people, like lions are there, for example, or elephants are there, whatever.
Yeah.
So, depending on the kind of work they do, like say lions, a pack of lions, okay, they do a very physically active in terms of, chasing the prey, running around, and then finally killing it and then eating that prey raw. Yeah. So, the amount of energy expenditure for all this is much, much more. So, for the animal to come back to a normalcy later, it needs that much more time.
Yeah, okay.
So that's why if they say lions sleep most of the times, they're only active when they're hunting. So that's how it is. So but again, for the same thing, if it is a smaller animal, or if the animal is not doing such highly intense works, then they may require less time to relax or get better. So everything is relative. It all depends on how much of your you have invested in the work you're doing. That much more relaxation you'll be requiring. To give another small analogy, if you have a smaller problem, it will take faster to solve that. If you have a much more difficult problem, it will take that much more time.
Right.
So you can take it in that way, in such a way that the body is trying to unravel a bigger problem, so you need more time for it. So that time it will sleep more.
So then, is it concerning if somebody sleeps for more than 8 hours or more than 9 hours? Is it a concern or is it just a thing that?
If it is, see, that's what. So what you have to see in this is that if you have anything else along with this particular sleep tendency, anything else is there. So any other symptom which is disturbing. Sometimes you sleep more. The person may be a little depressed. He may not have anything, going in his life. So he may find solace in sleeping, just like we find solace in eating sometimes.
Right.
So you have to find out this thing. If it is matching in that, then you have to try to solve that or get him out of that. But if it's just one of that, say you had a very tiring day.
Yeah.
Very tiring day. You tend to sleep more.
Yeah.
Definitely tend to sleep more.
No, so there have been days where I've slept like 11, 12 hours.
And that would have definitely been because you had already had a bad week or, very stressful week.
Yeah.
That's how it is. So
So, but if it becomes a pattern, then it may be something that you might want to check out
Yes,
with.
if it becomes a pattern without, as I told you, without the
Any stimulus as such.
without the intense, active day exertion you had, either physical or mental, then definitely it's a problem. As I told you before, the footballers, okay, they all sleep a lot, actually, if you ask me.
Yeah.
So that's how it is.
And you also mentioned something about, taking an afternoon nap. And then it is also considered unhealthy to have a nap right after a meal. So how does that work?
Yeah. So tendency is that when you take when you have food, okay, when you have food, what happens is the digestive tract is loaded with food.
Yeah.
So now what happens is the blood, in general, you have around 5 liters of blood running in your body. So the blood is pushed preferentially more into the digestive tract. Okay, because you need to digest the food, absorb the food. So for all that, there is more blood supply to your digestive tract. That is, through your parasympathetic system, the blood supply flows to the digestive tract. So in the process of the blood getting diverted preferentially to the digestive tract, the blood supply to your brain comes down. That is the reason you start feeling sleepy. So feeling sleepy after a meal is natural. So if you take a half an hour or whatever time your particular this thing is, you should take rather than not take. It all depends on your this thing. In the sense, if you feel like taking a nap, do take a nap.
Okay.
That's what I'm saying. Here, what is important is we listen more to outside advice than actually listening to our bodies ourselves. So that's where I come in. Because I feel like taking a nap in the afternoon on a Sunday. Because I don't have anything else to do after that.
Yeah.
Similarly, if you have already something in mind, irrespective of how much you've eaten, you'll still be active, isn't it? Because your body has made sure that whatever preferential, more blood flow going to the GIT, that your digestive system, still the brain is getting the enough supply. That's why you'll be active. So, but when on a weekend or a Sunday when you're free and you're eaten something in a good meal, that time because nothing is there in your mind, which is taking your attention, you tend to relax and then sleep. So, listen to your body, and if it says you feel sleepy, please do sleep for 40 minutes or half an hour, whatever it is. There's no harm in that.
Okay.
Yeah.
And this is, I think, a cultural part in Japan, where, or I may be mistaken about the country, but they do have the system where they just bring a little pillow to their desk. After a meal, they have a little nap.
That's such a good, healthy habit, if you ask me.
Okay.
Yeah, it's true. And that's the reason why we have even those words. You have a siesta, afternoon siesta. So that's the reason why we eat and then you take a brief nap. It may not be a complete like a sleep in this thing, but yeah, a 45 minutes or a half an hour nap.
So, doctor, tell us a little bit about what happens to our brain when we are sleeping.
Yeah. So, when we are sleeping, what happens is your active, inputs which you're getting, right? Inputs from your vision, inputs from your senses are all temporarily suspended. Okay. So, because of that, the stimuli which is keeping the brain attentive is cut down. Okay. So, once that the stimulus is cut down, eventually what happens is there will be the activity of the brain, the processing of the brain, all those things slowly come down, and then you reach a level of slow wave pattern, and then you slip off to sleep. So what happens is your active centers, which have been active most of the day, will take a break basically. In that break, the whatever metabolites, the byproducts of the energy being utilized and all that activity are being slowly flushed away from the system.
So the metabolites are what generally people refer to as toxins.
Yeah.
And so do you think that byproducts or metabolites is a better word to refer to?
Byproducts of metabolism is a better word, rather than saying toxins.
And what else happens? Like what are these metabolites, or why are they getting created, and how do they get purged?
So metabolites, see, whenever there is a particular activity happening, I'll give you an example of in the brain. Brain cell membrane is a membrane which has a potential difference of electricity.
Okay.
So that
Voltage.
potential difference of voltage. This potential difference is there.
Yeah.
So the potential difference is called resting membrane potential, RMP.
Okay.
Okay, so that particular RMP is supposed to be minus 70 millivolts.
Okay.
Okay, and that RMP is maintained through a particular particular part from on the cell membrane.
Okay.
It's called a NAK ATPase channel. Na means sodium,
Okay.
K is potassium, ATPase. ATP means ATP is the fuel of the cell.
Okay.
The unit of
adenosine triphosphate.
Yes, glucose is fuel, what you say, but actually glucose can convert it to ATP. So ATP
Okay.
is the most basic fuel of the cell, and so NAK ATPase is the channel through which the body actively purges out sodium from the cell and brings in potassium into the cell to maintain the resting membrane potential. So when you are actively engaged in activity, all from in the morning and whenever you are active, this RMP, what you call the potentials keeps fluctuating. Eventually from minus 70 it may get into minus 50 or minus 40. So then what happens is the function which ensues if when there is a RMP which is not correct, the not ideal, it will be definitely not that good. The whatever ensuing function will not be that good.
Yeah.
So in order to bring it back, it needs that little time to bring it back to normalcy.
So you gave you gave an example of a restaurant kitchen.
Yes.
Could you please repeat that?
Yeah.
for
So that was in the sense. So relaxation and repair happens as we speak. But what happens is when we are, like, say we are morning, when we are having say 8 hours of a kitchen which is open for 8 hours, and then you start making a first dish, and then though you're making the dish and you're still trying to clean it up and then put it back. No matter how efficiently you can do it, you still have some amount of spillage of this clutter into the kitchen.
Yeah.
Okay. So eventually after a period of 8 hours, there will be a significant amount of clutter which needs to be put back down into its position. So that's the thing.
And
Rest
while
has to
the
do
kitchen is working, that cannot happen because then it will reduce the efficiency
of the kitchen. So that's why you leave it for some time later. So that's what you do eventually.
And how is this purging happening? How is this flushing happening? What is the process?
The process so what happens is basically your blood flow. Basically, the blood flow, when the blood comes in contact with the cell, everything depending on the concentration gradients of these things. For example, there's oxygen deficit at one place. So the cell has utilized oxygen, right?
Yeah.
So, and then there is more oxygen in the capillaries, blood. So, preferentially the oxygen starts diffusing more onto the cell. Okay? Because there is a gradient is there. So, because of the gradient, it goes in. Similarly, there will be, once the byproducts of metabolism start forming, there is more of that concentration in the cell than in the blood.
Yeah.
So then it starts diffusing into the blood again.
Okay.
That's
and then basically your liver and your kidney are basically
then
pulling
they
that
will
out
eventually metabolize it and throw it out of the system.
throw it out of the system.
And then in this, so that's how it happens. This, when you are sleeping, what happens is the actual
Input is
not there, and also performance of that particular cell is temporarily suspended. Then what happens is it can easily remove all that extra gradient of the byproducts, and then it will be again pristine, in the sense ready to start again.
So basically you can say that sleep is the detox regime of the brain.
Yes, it is. It is not just for the brain, it is for everything, the muscle, all the organs, definitely.
And is this also why it is important to drink water?
Yeah, see, drinking water, hydration we can call it. So hydration is again one more essential part of being healthy. Because as I told you, our body is made of 60% of water. So whatever chemical activities which are happening in the body are happening in the fluid in a medium. So the medium is water.
Solvent.
Yeah, maybe. The solvent is water, and the proteins and other substrate, sodium, potassium, all these are solutes. So that's why you need that water to keep, keeping it to the optimal level. Otherwise, eventually, things can go wrong. So that's why hydration is really important.
And doctor, we spoke about sodium and potassium, and we know that there can be low sodium in somebody, and that leads to their brain not functioning as much as it should. People don't they're not fully conscious, or
Yes,
they
true.
have
So that entity
why?
is, that entity is called hyponatremia. So so that directly affects the signal transmission. Okay, because as I told you, when the signal actually starts in a membrane in the brain, the minus 70. So what happens? The minus 70 is the millivolts of the. It's a potential difference between the external of the cell and internal of the cell.
Yeah.
Okay, and that is maintained through something called the sodium-potassium gradient.
Yeah.
So suddenly this signal happens because something of process called depolarization.
Okay.
So depolarization में क्या होता है? Basically, the minus 70 becomes plus 35 or plus 40.
Okay.
So suddenly there will be an influx of sodium into the cell, and then the influx of potassium out of the cell. So that again suddenly changes the potential difference, and the signal transmits. Okay.
Okay.
So when your sodium itself is low in the blood, that it's definitely will hamper the restriction potential of the body, of this cell membrane. That's the reason why you develop all these problems.
So how do we get to know that our sodium is low? Is there a way for us to find out apart from tests?
Yeah, the problem is, sodium being low in the general population which we are having right now is because of the antihypertensive medication which we have started, and also the context of taking low salt for hypertension. So because of that, the whole tendency of low sodium has started off. Otherwise, we never had this problem of hyponatremia, that is low sodium, in our bodies. So in elderlies, when you have this low sodium, they will initially show some features of lethargy, fatigue, irritability can be there. Eventually, patient can have seizures also. So that's when but you shouldn't go to that level. That's the reason why anybody who's a hypertensive and taking hypertensive medication should regularly check his or her sodium.
Electrolytes.
Yes, electrolytes, yes.
Nice. Now that brings me to something else, which is the spine, right? See, all of these things are interrelated in our body.
Yeah.
And, something because of hypertension, nobody would think that, their sodium is going to go down. They're going to feel fatigued all day and so on. Similarly, there is some sort of overlap between some areas of medicine, some specialities. For instance, somebody has a problem with their spine. How do they know whether to go to an orthopedician or a neurologist or a neurosurgeon?
Yeah, so this confusion is there, but I guess both specialities are managing spine. Orthopedicians were initially the initial people, doctors who used to manage spine, but then neurosurgeons also were managing spine, but we are managing spine which are more close to the brain. So that is something called as a CV junction, craniovertebral junction area, or cervical spine, the neck area. So that was managed more by neurosurgeons and less by orthopedicians. So that's it. That's how it evolved. So now the present scenario is that both are managing spine, but a lot of orthopedicians generally, try to give it off to a spine specialist. So now we have spine specialists who both neurosurgeons also can become or orthopedists can become. So that's how it is right now.
Is it something like a subspecialty?
Yeah, it's a fellowship or something. Yeah, so we do that. But having said that, any doctor, consultant who has a name in the particular field, the spine field, can treat, or you can go to that particular person. So that's how it is.
So do you think it should rather be in a way that you first go to a general physician? If you have an issue, you go to a general physician first. They analyze the initial symptoms, and then they refer you to either an orthopedician or a neurosurgeon, something like. Can that be
I guess that is the way it happens in most of the countries where, like say in UK and all that, where NHS is there.
Yeah.
Neurosurgeon is not accessible directly to any person who comes for a referral. So it usually is seen by a general practitioner first, and then he decides whether the patient has to go to a neurosurgeon or not.
Okay.
And in India, it is different. In India, we have access to anybody, all the specialities, like in private as well as in government colleges.
Yeah.
So, if you are aware and if you are knowledgeable about your symptoms, people do come with those symptoms of spine or whatever to neurosurgeon. But in other sense also, if the people are not that aware, they usually go to a general physician or a general practitioner, and they usually refer to us. So, both things are happening in India right now.
Okay,
Yeah.
but can it be, would a patient be wrong to directly go to one over the other?
No.
No such thing.
There's no such thing like that, because eventually, if the symptom doesn't relate to our, like say, neurosurgical issue or a spine issue or a brain issue, you would always refer it back to the person, like this
ortho
necessary
right.
speciality. Yeah.
So now, when somebody goes to a doctor, the first thing they go to a doctor is because they have some symptom. One of the easiest symptoms to spot is pain.
Pain.
And I've heard it said by somebody, being said by somebody, that pain is not actually in one part or another. Pain is in the brain. So is that accurate to an extent, or is it?
It is definitely accurate. To
Okay.
not an extent, it is accurate to the most of it.
Okay.
Because the whole processing of pain happens in our brain.
Okay.
Okay. Just like touch or just like vision, we are able to perceive vision. So similarly, pain is one more sensation, which is finally perceived by the brain.
Okay.
So it is something like you have sensors all over your body, and then there is a stimuli which is not good, it's harmful for your body. Then you get the perception of pain. And it has different layers to it. Like say, if you have a small pinprick, you have a sharp pain. And
Yeah.
if you have a bad pressure or something, you have a dull pain. So pain has multiple, layers to it. So yeah, definitely gets processed in the brain finally.
So, there is this negative connotation to pain, right? Pain is undesirable. But do you think it is actually a good thing?
Yes.
That you feel pain?
See, pain is one of the first symptoms. The body is telling you that there's something wrong happening in the body. Okay. So rather than trying to look at it or trying to, go inward and see what's happening, we try to outwardly, take support and help from other people. In fact, if you're having pain is the first, as you rightly said, it is a symptom. You can't say it's either a good or a bad symptom. It's just telling you, it's just saying, hello, hey, there's a problem.
It's an indicator.
There's a problem here. You please look into it. So, I'll give you the very simple example for that. Is that now since we have become sedentary, always sitting, and we don't do physical activity as much as we used to before, we not able to, utilize our back enough. Okay,
Yeah.
the muscles get weak and the bones are getting more pressure because we always slouch and sit like this. So eventually, what happens is the muscle is not supporting the back enough, the bone is fine enough. So the bone, since it is hard, it will tolerate that stress. But between the bones, there is something called as a disc, which starts getting damaged or getting degenerated because it is not being supported properly.
Yeah.
Because when you are erect and proper posture is there, the muscle actually supports it well, so that the stress is not directly falling onto the disc. But then due to our habits, the disc gets damaged and immediately you will start having back pain. Now, what do we do for the back pain? We, in order to prevent our performance and our routine activity to get compromised, we pop in some painkillers or some muscle relaxants, and then we continue to do our work. So, in this sense, you're ignoring the pain which is coming from your back, and you try to continue your activity.
Yeah.
So, with this, what's happening is the painkillers, what they do is they reduce the pain by reducing the inflammation around that area, because something is injured there, and the inflammation is the one which causes pain, the sustained pain. The sustained pain is caused by the inflammation.
Okay.
So, that is reduced by the painkiller, and you continue to do your activity. Now, what happens? You can guess, take a guess. So, inflammation is reduced. So, the injury is not repaired yet.
Yeah.
And you are back to your normal activity. So, the injury increases.
Increasing the injury.
The injury increases, and I have seen this n number of times in my practice, that patient would have taken a muscle relaxant or a painkiller and gone back to work, and another in a week's time or in a 2 weeks time comes out more severe pain than he was before.
Yeah.
So if you had listened to his pain, it's telling you that this particular moment is causing me pain. So what you should do, you should avoid that moment. Very simple. So in spine, any sitting posture will cause pain. So that's when you should lie down. So lying down will offset the pain, and you have to give the time for that injured area to heal, which we don't do that. So
but then it would not also make sense to say whenever we have any sort of pain, we just go to the doctor. That would be a bit of an overkill.
Yeah, it is definitely not.
Yeah.
So that's the reason why you take rest. You don't have to go all the time to the doctor.
Yeah.
So when the pain is not getting better with your what you're trying to do, then you take help from a specialist, isn't it? That's how it is.
Yeah.
So what we used to do before, I'll give you an example. When we were probably 30-40 years before, when we had this kind of symptoms, we used to take some amrutanjanam or something and then we used to sleep. So the sleep used to take care of it. It used to repair the whole thing.
Yeah.
So that we're not doing nowadays because we're so busy with our work. We have to finish some. We have deadlines to meet and all that, and then we are, I think, spoiling our body. We're not listening to what's inside, what the call from inside basically.
So there are different kinds of pain, right?
Yes.
So what are those different kinds of pain?
Different
from the medical standpoint, from the physiological.
Pain is actually a pretty vast topic.
Yeah.
As in, okay, I can give you a little heads up on that. So there is pain which can be specific, like when you say that there is something, a thorn pricking you.
Yeah.
Okay. And then there is a pain which is very dull as well. Okay, it's very diffuse. You can't really pinpoint to one particular thing. So this pain, these two are they're given different names to it. Okay. One is called a somatic pain. That means you can actually pinpoint one area, and there's another dull aching. So that is visceral pain, you can call it. So so this kind of a pain has different set of nerves and neural architecture behind. Okay. So eventually, but then there is an area in the brain, okay, which takes care of integrating all those things. Okay. So there's a place called thalamus. Okay.
Yeah.
Thalamus is a place where all the sensory, not just pain, all the sensations get integrated, and then you get an understanding about the pain and all those things. So it's if you really want to have a discussion, probably we can have a discussion only on pain once, so that we can really elaborate on the different kinds of pains as well.
Sure, we'll do that. So we'll do one episode that is going to be dedicated to pain.
Yeah.
We're going to talk about all that we common people can understand from the non-medical standpoint. Now, you said something interesting about the cervical spine.
Yeah.
So am I understanding it right that that's the thing that's the place where your brain is getting connected to the spinal cord, right? How is that related to midbrain?
Midbrain is little higher than the cervical spine.
Okay.
So midbrain is basically part of the brain stem. So now since you brought the topic of midbrain, brain you can generally divide.
Okay.
Just for our understanding basically into the one which is the higher here, that is the cerebral hemispheres. Okay, then you have cerebellum that is behind here, and then the brain stem because it's a linear single column like a stem, that's why it's called a brain stem. And midbrain is a part of the brain stem, the uppermost part of the brain stem. So, and your cervical spine which is there starts off, once the midbrain is there, the second part is called the pons. Okay, the last part of the brain stem is called the medulla oblongata. Okay. And then from medulla below is the cervical cord, spinal cord. Okay. That's where your neck is.
So, there was this interesting thing that was happening around, this was primarily concentrated in Kerala if I'm not wrong. There was this thing called midbrain activation.
Okay.
And this was a whole racket going on where somebody said that we have some exercises that are going to activate your midbrain and that will make your kid like super smart. They'll be able to close their eyes and see what is going on.
So did it happen finally?
Yeah, I mean, I think like most things, it kind of died down. Yeah. But when I was reading up about this as to what midbrain actually was, because I got interested.
Okay.
So I was reading about all these things. That's when it mentioned that the midbrain portion has some very significant role to play in, our general being.
Yeah.
So, one part of that was called substantia nigra, if I'm not wrong. And that was what was supposed to produce dopamine.
Yeah.
Can you tell us a little more about dopamine? What is its role? And why is it important?
Yeah. So, I'll start off with the midbrain thing, whatever. So, midbrain is definitely, it has all the centers which create awareness, in the sense there is something called as ascending reticular activating system.
Okay.
Ascending reticular activating system, or in short it's called ARAS.
Okay.
So that ARAS, the centers, the neurons which create this kind of awareness. Okay. So those neurons, nuclei means a set of a bunch of neurons basically.
Okay.
So they are present predominantly in that area, midbrain.
Okay.
So why this reticular system is important is because this is the neuron which connects all individual neurons of the body. For example, you have a neuron of vision, and you have a neuron which is supplying your, which is taking care of your sensory symptoms. And there's a neuron which is some other doing your hearing functions.
Yeah.
Now this neuron interconnects those neurons.
Okay. It's like a junction basically.
Yeah. Not just junction, it interconnects basically. It's not a junction. Basically, it is a little bit of this it takes and gives it this, and then in the sense a stimulus from vision, it transfers to some other place, to some other area. Okay. So it has these connections to all different sorts of neurons. Okay. It also has connections to the motor neurons also. Okay. Which give you motor function.
Like sensory neurons connecting directly to the motor neurons.
It just gives awareness. So, in the sense that this one particular neuron will be aware of the other fellow also, because of this interaction. So that's what creates awareness. So that's the reason the reticular system is our seat of awareness basically. Like the sense of self, what we talk about soul and all that. No? We can probably indirectly say, okay, if your reticular system is not active, probably you are not aware of yourself. Okay. So that is what it is. And if they are doing something to enhance that reticular system, fine. But always there's a limit to your enhancement of awareness, right? Yeah. So.
And is it safe to say that midbrain is already active? If you're talking, if you're seeing things, it's already active. There's no need to.
As we are talking, as we're interacting, the signals from our vision neurons are also going to reticular system. It's also going to my other neurons. So that's gives that concept of awareness completely.
Okay.
So, and you also talked about substantia nigra and dopamine.
Substantia.
So the dopamine is one of the neurotransmitters. Okay. So just like serotonin or acetylcholine, so you have some neurotransmitters.
These are chemicals.
These are chemicals where the nerve has something called as a synapse. Okay.
Yeah. So the connection point.
One neuron connecting, one branch of neuron connecting to another branch of neuron. So in that synapse, when you have this neurochemicals released in that, you can either have a positive signal which gets progressed, or a negative feedback. Either you get a positive or negative feedback. Okay. So dopamine is more of a positive feedback neurotransmitter. Okay. So with dopamine, what happens is when you do a particular activity, perform a particular activity, and if you do it well, you finish it. Okay. To its completion. Yeah. Then this dopamine gets secreted more and more. So it gets a positive feedback. Okay. That is the reason you get a high when you do a particular activity, which to your satisfaction. Yeah. So you say jog, or you run for your 10K or a 5K. Yeah. Or you perform a mental task, which is very difficult. You get a high. That's because that many neurotransmitters of dopamine is being released to do a particular task. So that task is a little difficult. That's why that transmitters are getting released that much. Okay. That's why you feel that high. Okay. So it's a positive feedback a positive neurotransmitter basically.
This addiction to dopamine.
Correct. So what happens is sometimes we do have other sets of neurons which we don't know what exactly they're called, because we're not yet clear about it. We talk about mirror neurons in neuroscience terminology. So we feel empathy. Say for example, you are hurt, we feel empathy. You also feel bad about it.
Yeah.
Or your particular superstar, or your like say Ronaldo, okay, is scored a goal, and he has won a particular this game. So you feel good about it.
Yeah.
As if you have done the thing. So these are basically, we don't know exactly which particular neurons are active in this, but we generally call them mirror neurons.
Okay.
So with this, what happens is indirectly also the neurotransmitters get released. You have not done that activity at all.
Yeah.
You have not done the physical activity, actually going and kicking and making a goal.
Yeah.
But still, you feel a high because you empathize with that guy. So this is basically a dopamine surge, which you get indirectly as well. And this is exactly the main thing about forming habits as well.
Okay.
So there are situations, there are chemical, like say smoking is one. Smoking will give you that high. Okay. So that's why you get hooked to it, because you get a good feedback. Okay.
Okay.
And in smoking, it is not dopamine, but it is something else. Nicotine, basically.
Nicotine.
Nicotine gives you the high through acetylcholine. In the sense, it again is a positive neurotransmitter, which gives you a positive depolarization. So that's the reason why you get hooked to it. Similarly, some other drugs which give you that high, again cause the same thing. They increase the neurotransmitter levels, giving you this thing.
Okay.
So that's why habits are created. And the same way, you can actually develop a good habit where you can actually do a particular activity, and then you get that high.
Yeah.
Like in running. So when you do that, you get a high, and then you get hooked to running.
Yeah.
So a lot of people are there who are real, like crazy.
I have a friend who is very crazy about it.
That's because they always get a high when they do the running part.
Yeah.
So it's better to form good, better habit forming rather than a negative forming, basically.
And then with the midbrain, you said that it's basically connecting different kinds of neurons.
Yeah.
Is this also the place that is responsible for reflexes? Or is it a whole different thing?
Reflexes, see, the whole brain is made on reflexes, basically. At least the involuntary brain.
Okay.
In the sense, there are a lot of times now I'm talking to you. Suddenly, if something, pricks me from behind, reflexively I'll move out.
Yeah.
Irrespective of whether my thought goes there or not.
Yeah.
Right? So that is called reflexive part. So the reflexive nervous system is actually, as I told you, it's all multi-layered. So the reflexes come at the most basal layers. Okay. So there are multiple reflexive brain, and on top of that you have a thinking brain. Understand?
Okay.
The aware brain. So this aware brain is different. Different as in it will function differently, and your reflexive brain always is there. It is running behind us. It's like a backdoor and back-end team of any company.
Yeah.
So it will be running irrespective of what's happening in front of you. Like reception is your actual office, but behind you so many things are happening.
Right.
So like that, this reflexive brain is different completely, and it is always on. Even when you're sleeping, also reflexive brain is on.
Works.
Actually.
Yeah.
Yeah.
And then you said that the midbrain is a seat of awareness.
Yeah, the nuclei are there basically.
Yeah. So when you're sleeping, what happens to this part?
Yeah, so obviously when you're sleeping, because as we discussed before, the inputs from the individual neurons of vision, of the sensations are all gone. So eventually the awareness also, the inputs to reticular system also keeps coming down. Because the inputs eventually come from these centers. That's the reason why the awareness also comes down and you'd go to sleep.
Okay. Now, how is sleep different from a coma?
Yeah, in coma you can't come out, you can't wake up from a coma.
Why?
Yeah, that's because these main centers, like in reticular system, whatever I talked about, they can be immediately brought up to action by when the stimulus goes in from all centers, the awareness can come back again in sleep.
Okay.
But that doesn't happen in coma because those centers themselves are injured. So when they're injured, whatever you try to do, it doesn't come out. So, but then it takes time for it to repair itself and then come out of it.
So you're saying there are chances of somebody coming out of coma.
Yes.
That's why they say we don't know.
Yes, true.
When, but they can come out because some neurons do end up repairing eventually.
Yes. Repairing does happen in the neurons, in the brain. But that repairing takes a lot of time because that synapses which already have formed, that meshwork of synapses which have formed, for them to form again, because that synapse is like on slow one, they are like this, okay?
Okay.
One branch going slowly and then connecting to one more, what do you call this thing? So, that happens, takes time. It takes time a lot. So, that's the reason why we can't say how much. And it also depends on how many neurons have got injured. If less is injured, it will take less time. More are injured,
So, is it possible to surgically join nerves?
No.
It's not possible to surgically join
nerves. You can, mechanically, we can just, what you call, get them close. But eventually the tubes, the nerves are basically tubes, right?
Okay.
They're axons, they're called, right? The axons have to combine, unite. So, axons uniting doesn't happen with, we can't do it. It has to happen naturally. Yeah.
Right.
So that's the reason why neurons don't, heal that well.
Okay. So I think we'll wind up this episode with these questions, but like even through this discussion, I have now got like a bunch of questions in my head.
Yes.
So we'll probably have to do another.
You can note it down and then we can discuss it
I will note them down and we'll have another follow-up episode. Sure. And so we'll meet you again. For now, this is it. If you like this episode, please make sure you hit that like button there. And if you would like to see more of this, ensure you subscribe to the channel. We have a lot more videos coming up. We have the subjects ready and so on. And if you don't want to miss when we upload a video, please do hit that bell icon. That will actually help you, help us reach you quicker than, you accidentally finding us in the feed. So that was it. In this video. We'll see you again in the next one. Until then, take care.
Thank you.